And so TeacherTrack runs, it's a .NET 4.0 application, and believe me, we started in beta 1, so it was a little dicey in the beginning. And it's primarily an ASP.NET Web Forms application, but my kind of attitude is to bring in all kinds of fun, cool stuff. That's why we switched to Mongo first of all. No, I'm just kidding. So we brought in MVC also. We used WCF and Workflow Foundation 4.0, and basically so much more stuff in the .NET ecosystem that I probably couldn't list it. But we also, for SQL Server, we used Hibernate, which is a very big ORM. We use the MongoDB.NET driver. One really cool thing that is very recent in TeacherTrack is we use Service Bus, which is a message queuing system. And also just like at XFM, there's a big search component also, and we use Lucene.NET, which is what Solar's based on Lucene. And Lucene.NET is a port of Java Lucene.NET. And much, much, much more. Okay. So I'm going to just quickly talk to you about the data structures that really helped, the data structures that we wanted to move to MongoDB. And so basically, one of the biggest data structures in the whole application is this thing called a survey. And basically, a survey is almost analogous to a survey template, to a survey in SurveyMonkey. So like you go in and you can define questions, and you can say like, hey, this question has a drop-down list and these are the choices. And it actually has a lot of rich options. There's dependencies, and there's actually questions that can like work like Excel formulas and like add up other questions and do summing. And there's a whole big system. And basically the starting point of a survey is a survey template. And essentially a survey template is like, if you think about like a teacher who's making a test for their class, and they make up the test, then they go to the photocopier and they put it on the photocopier, they say 30 copies, and what they put in the photocopier is the template. And basically in that template, it contains some header data, basically like what site the template's for, and what like its primary key, and a name, and also it contains an array of questions. And the questions contain things like the text, as well as rendering properties, like what options would be in there, or should it be a drop-down, or what's the watermark in the text box, stuff like that. Okay. And a survey is essentially an instantiation of a survey template, like a new object. And that contains header data, just like the survey template, but it also contains data that associates that survey to a user. And it also, instead of having an array of questions, it has an array of responses. But the responses are actually kind of special. Not only do they contain the response, like what a user would select in the question, but it also contains essentially a denormalized piece of data that was the original question. So basically the advantage of this is that we don't need to go back to the original template to get the question data, and we only need a survey, and a survey can stand alone. Okay. Now I'm going to just log into actually New York City's site, so that if you want to become a teacher in New York City, one of the ways is you can go to this site and apply. Typing is fun as a presentation. Okay, so now I'm going to log in with a very long email account. So now I'm going to log in as an administrator. And so the first thing I want to just quickly show is these survey templates are extremely customizable. So I'm just going to quickly go to a feature that we call the question bank. And this is like what your application would be if you wanted to sign up as a New York City teacher. And so this is an administrative UI that actually lets people come in and edit a question and change things and affect appearances and turn on and off questions and make things required. And I'm going to just bring up a random survey and show you what it looks like. So hopefully I can find someone that can bring up a cool survey.
Maybe try Philly for the spot.
And so basically, like, surveys in the system there's many different surveys, obviously, and you get certain surveys at certain times depending on what state you are in the system. So I just kind of wanted to show you guys a kind of more complicated survey. Okay, so a lot in here. We should definitely have people in the right state here. So I'm just going to look at this user's profile, and everything is kind of obfuscated, so you're not seeing real live data. And so what I'm going to do is I'm going to bring up someone's profile right now. And I'm going to go in here and I'm going to train it. And I'm going to make let's go with these rubric. So this is a rendering of a survey. And one thing that's really cool about surveys is it actually has many different rendering modes. So like right now we're looking at an HTML rendering mode of a survey, but we can actually, or this is what we would basically call an editable mode. We can also render this as read-only, so like we're going to display this for someone. We don't want them to edit it, obviously. And we also have ways to output these to PDFs, for example, as well. And so basically, like for example, right here, I'm going to select an option, and what's going to happen is other options are going to appear because they're dependent on that question's responses. So things like that. And I think that's good enough for the demo. So now you guys got a hang of what a survey is, but just before I close it, essentially these are questions in Mongo, and this is the survey. And the values that I choose are responses. Okay, so now let me just show you guys quickly what our objects look like. So one thing I noticed about the Python demo is it was really decorated really hardcore with like helper stuff for your ORM library. And one nice thing about the .NET libraries is you kind of don't need to do that. So that's nice. So basically we just have like a regular class. And in the .NET space, the way they would refer to this as a POCO, a plain old CLR object. And basically this is, so this is a survey class, and I'm not sure how many of you guys are familiar with .NET or have a Java background, but there's an object called list. It's a fancy array, for anyone that doesn't know. It basically contains a list of responses. And so when we were mapping this within Hibernate to SQL Server, we had one table for surveys, and then we had one table for responses. So in essence, if you had a survey with 20 questions in it, we had 21 rows. One row in the survey table and 20 rows in the response table. And every time we wanted to query your survey, we join the two tables and get your data out. I got PowerPoint here, sorry guys. So that worked really, really well for a long time. And then all of a sudden we had a lot of data. And I don't know if everyone here has experienced joining tables with millions of rows, but it doesn't always go so good. And in fact, to get one survey out of the database, it could take actually upwards of 200 milliseconds. And there's pages, like the page that I went to create that new survey, that page is trying to load every survey for a specific user. So we can be loading upwards of 20, 30, 40 surveys. And so 10-minute page load time, 10-second page load times, they're not fun to work with as developers, as testers, and definitely not as users. And at the time of the conversion, we actually had over 1 million surveys and about 16 million responses. So that was definitely one challenge, the performance, and that got us to really start investigating ways to fix that. And just to back up, we didn't convert. Our first thing was, let's throw out SQL Server. We said, how do we work with SQL Server and make it faster? Well, we didn't just have two tables originally. We had several tables, and we were joining multiple joins, and we got everything down to those two tables. And still, it was still too slow, and so we started to look in other places. But another thing is, at TNTP, the teacher track team it does Scrum, and we're huge believers in Agile and iterative development. And when it takes 20 minutes to run an alter table, which we've had before in the past, scripts aren't expecting that generally. Like things that run deployment scripts aren't expecting a one-line SQL query to run for 20 minutes. And so things break, things time out. We don't, and it's not always clear why. And just in general, it's not fun to run a 20-minute alter table, especially 19 minutes into it. You're like, I wonder how long this is going to take, because there's no, obviously there's no percentage counter or anything like that. So we needed to switch to a NoSQL solution. So there's so many of them. How do we decide? First of all, we selected MongoDB. So I kind of took some time and I made a branch on our code and I started prototyping with a couple different solutions. One of them that we tried is not very big, I guess, in the NoSQL community right now. It's called RavenDB. It's for .NET. It's written by .NET people, and it's all in .NET code, and it's like supposedly really easy to work with. And it was easy to work with, but there were some challenges with that. And so I said, let's look at some tried and true NoSQL solutions, and we looked at lots of them, but I kind of settled on MongoDB. And clearly the best three reasons are performance, durability, and scalability, right? So the first thing is, since we're storing in documents, we don't need to worry about how the relations are going to work. We can have a really rich schema in a document. And the other thing is, I didn't know it at the time, but replica sets, which is the MongoDB durability story, is extremely good. I really like the way they work. They're kind of like you just set it up and you walk away and things go well. And the other thing is, auto sharding is super cool. And I will tell you that TNTV does not do sharding yet. They have one replica set. But it's always an option in the future. And it's something that we were talking about from day one because we have big dreams for all the data that we're going to store. The other thing is, 10gen absolutely rocks. From the moment that I contacted Sarah for training, I had really good engagement. And I'm not saying anything about other companies, but like when you use SQL Server, you're just like some little rounded number on the bottom of a balance sheet. And I know a lot of people now at 10gen, and that's, that can't be understated. And the other thing is, they have really cool tools. Like, we already spoke about MMS a little bit. It's a great way to monitor your servers. And the other thing is, the training really helped me. Well, I would say if you guys are switching to any NoSQL solution, definitely seek out the company that's that backs that NoSQL solution and try to get training with them. They obviously know how to use their product better than anyone else. And from the minute I walked into training, Sarah was actually bringing me out and introducing me to different people. And when you get put in front of engineers, there's a good situation happening there. When you get put in front of marketing people, it's definitely not the same situation. And so surveys are a great match for MongoDB. One of the things that people do is, and you guys had that problem too, you guys have a document with an array of likes or loves, and then you have a problem balancing them, right? Well, the problem is if you have a document that has an array that can expand, and then another document next to it, and then you go to expand that first document, oops, we got to relocate you. And so that's a big challenge that people face using MongoDB. But what's so good about surveys is once we create the document, we're never changing the response. We might change the contents of our response, but we're not adding responses in, for example. And so it's a really good use case. The other thing that's really good about it is we can get sub 10 millisecond query times from the server, and that's on test hardware, not production hardware. So I would very much assume it's even faster than that. And so now I'm going to just talk a little bit about how we wrote the conversion tools and our philosophy behind that. And so basically there's three simple steps. There's like the source query, like get the data out of SQL Server. Then the second step would be take your source data and convert it into your destination object. And since MongoDB uses BSON, we actually kind of instead of using the object, we took the object, got it into the final object, and then converted that object into BSON so that we didn't need to do any serialization in the third step, which is writing that data into Mongo. So one of the key things that we did right away, I wrote like a quick proof of concept in a big loop, and it was very slow. The data took days to convert. It's kind of one of those things I turned on actually, it might not even, I think I was in a draft, I wrote the days that I did it on, but I think I started it on a Thursday night. It went all day Friday, I couldn't use my computer. Like, it went all weekend, and then finally Monday, thank God, it actually finished and it worked. We were able to do a lot of testing with the converted data, but we knew that the conversion tool was not where it needed to be. So basically what we did was, we actually, and I'll quickly go back, we structured the tool so that each step was in its own thread. And so we go and query the data from SQL Server, and then once we got results back, we pass it into an intermediate queue. And then this converted to BSON thread would be kind of in a loop perpetually saying, is there something in the queue for me to convert? Is there something in the queue for me to convert? And then it would get something, convert it, and then add it to a second queue for the third thread, which is the insertion thread. And we didn't do any bulk updates. We actually inserted one at a time. But MongoDB is so fast, it really, I did testing, what if we inserted in batches of like 100 or something, and it was no faster. So the other thing is, if you're in the .NET world, this object, system.collections.concurrent.blocking collection of T, that is the godsend of this conversion, because essentially that was the queue object in between the threads. And the blocking collection, that sounds like a dirty programming term. It's like people don't want blocking things. But actually, it's a really good thing in this case, because what was blocking about it was when the thread was saying, hey, give me something to convert, it blocked until there was something to convert. And the way it works is you give it a timeout and it takes a time span object, so you can give it in minutes, seconds, whatever you want. And then essentially, if you don't get an object out in that time span, you can decide what to do. So you can try again, or you can do fun stuff. Obviously, in our case, we tried again. And the other thing is there's a method on that queue called complete, mark complete. And then basically when I'll go back to it again, when the querying was all done and we got all the data out of SQL Server, it would tell the intermediate queue, we're complete. We've completed adding stuff to you. And then this thread, once it's converted all the data, it would block for whatever the time span was that we set. And then it would fall into we didn't get data, but we've timed out part of the code. And we would just basically say, hey, queue, have you been completed? And if it was yes, then we knew we were done there, and we can complete this thread, which then would say to this queue in between these two guys, we're completed, which would notify the insertion thread that we were all done here. It goes without saying, these things take a long time to run, so it kind of sucks when you do a conversion for 19 out of the 20 hours and there's an exception there. And so testing if the queues work properly, it worked the first time, and thank God, because we didn't really want to keep running this all the time. Go back to this next thing. Okay, so that was one key thing in our conversion. The next key thing is this thing that we kind of all came up with on the team called auto batching. Clearly, we're not going to query all 19 million rows in one query. We're going to run them in memory. SQL Server's going to think we're crazy. It's not a good situation. So we're going to do batches. And so we originally wrote it to do 100 or 1,000, some kind of number every time. But it's kind of weird. SQL Server, the way it stores data on disk, we'd have batches that took 2 minutes. It would be 2 minutes, 2 minutes, 2 minutes, then 10 minutes, 10 minutes, 10 minutes, then 45 seconds, 45 seconds. It was weird. So it didn't vary every batch, but it had groups of varying batches, I guess you could say. And so what we did was we kind of wrote a thing that would time each batch, and then we had a target of time which we wanted to make each batch. And so they would just do some quick math that someone helped me out with. And it would basically adjust the batch size as needed for the next batch based upon how the last batch took. I also want to say, I didn't put it on the slide, but you should definitely have something in your code that if it wants to increase the batch size like crazy on the next batch, only let it go 50% bigger at any time. We actually never tested, we never had that problem because we just put that in from right away. It's kind of like we don't want our code to hurt us kind of situation. And what this did was, this was always supplying data to our other threads. We didn't really want to, clearly the slowest part of the conversion was getting the data out. And so we wanted to kind of keep giving everybody else the data that we could get every minute. Instead of waiting 5 minutes, getting just this chunk of data, converting it really quickly, and then waiting 5 more minutes for data. So we wanted to be always writing data. And then there's one other thing that makes this whole thing really possible, which is incremental conversion. And so it took, even though with the multi-threading it took 20 hours instead of days, it's not a great discussion to have with stakeholders like, hey, we have to turn off the site for 20 hours because obviously the new code that we're going to deploy is expecting it to be in Mongo. The old code doesn't know how to talk to Mongo, so we have to run this conversion tool in the middle. That's not a good conversation. And so kind of the answer to that is let's pre-convert almost everything. And so what we did was a couple days before we deployed, we ran the whole enchilada conversion tool on the data set, and it converted every piece of data from the beginning of our data set to the end of that time. And then when we did the final deployment, in our little deployment window, we ran the conversion for the last couple days. And that took minutes and not 20 hours. And basically, it's pretty simple to make this work, as I'm sure you guys can figure out. We just basically had a modified on day field. A lot of programmers, or a lot of projects that get really big, you see it sometimes it'll do an update to the data and not flip that modified on to right now. So we made sure we did a lot of testing. We made sure all our code always updated that date. That date is, if it didn't get updated, it wasn't going to be converted. And so it was extremely important that that piece of data always changed when we changed any other piece of data. And then the other thing that helped us do this is that we never deleted surveys ever. And so basically we just had a little bit on a field on the object that marked it deleted. This way we didn't need to, if we were deleting data, how would we know that it was deleted? Because it wasn't there to know it got deleted. So from a non-business rule perspective, that's how we had to figure out how deletes worked. And so what was really, the basic thing is, say we changed data from a survey 3 months ago in the last 3 days after we did the main conversion, it would essentially just overwrite every insert was doing really an update. It was doing an upsert, it's called, on the ID, and then setting the whole document. So if a piece of data changed, it would just overwrite the old record in the database. And then the way we specified to the tool when to convert from is we just made a command line switch. Give me a date. Okay, so I'm going to talk a couple things about some lessons that we learned. First thing is, obviously, practice makes perfect. So practice makes perfect. Being a Scrum team, we work in sprints, and we took stories over 3 sprints, so that's 9 weeks to first come up with a schema and write a basic converter, and obviously we had to port a lot of code in our application also to work with Mongo. And it's like when we use these surveys in almost every piece of our system. So when you're making such a huge change like that, I had to have a meeting with our testers saying, you have to test this. It was like the list was longer than there were days. And they did a phenomenal job. And I always say the testers make me look good. And they definitely did here because they did a great job and we didn't have bugs. And that was one thing. The other thing was, and I learned about this in my MongoDB training class, but oh well. When we set up the production servers, and we're in a replica set. So just for those who are not familiar with the replica set, basically the replica set uses this thing called an op log. And an op log has primitives of what has changed in the data set. and the secondaries read the op log and use that to apply the changes to themselves. And so that's how the replication works. And so when you start up the replica set for the first time, MongoDB needs to size the op log. And so it's using a feature called cap collections that have a specific size. And I think the formula that it uses is like 10% of available disk space. We had brand new servers, we had this huge, RAID situation going on, and we had 400 gigs of available space, which gave us a 40 gig op log. Our servers had 48 gigs of RAM, and the way that MongoDB works, as I'm sure a lot of you guys know, uses memory map files. So once we want to, and the op log, by the way, is just like a database in the app, just in MongoDB, just like any other database. So you can actually query it. It's really cool. So because it's just a database, it needs to be loaded into memory, and it's 40 gigs. So there's 40 gigs of our RAM right there, and that obviously wasn't going to jive. So like the first hour of setting up our production server, I had already started getting into internals and resizing op logs, and we went with 3 gigs, but that was a complete guess. I think it was conservative of a guess also, because just looking at the size of our data, each survey is about less than 20K in terms of size. 3 gigs is like months of changes. And actually, MMS has really good reporting on how long your op log is. And basically, our op log got to be, every day was another day longer for months. And so that's a lot of time. So essentially, a server can be months behind and still use the op log to catch up, which would be a strange scenario. Like you didn't notice your server was down for months, but yeah. And then one other gotcha that we hit the first night. I was so insane with running the profiler, and there's really cool profiling tools in Mongo. So I turned on the profiler and I'm like, let me see all the slow queries. We're gonna squash all these right away. We're gonna get this thing going good. And that night our scripts ran to the first night that our scripts were running to back up Mongo and move it to some other environments and do all kinds of cool stuff. Well, when you back up, one of the ways to do backups is to do this command called fsync lock, which kind of tells Mongo, hey, flush all your non-flush data to disk and hold up all the writes, and we're going to just take these files right now while you're running live and copy them or do something with them. And you can't fsync lock if the profiler's turned on. And that wasn't in any documentation. And you were in my class, so you know they didn't say anything about it. So all our scripts broke the first night, 2 in the morning. But luckily I was insane and I was up at 2 in the morning monitoring it. And I added a ticket for Tengen. And by the way, if you guys have any problems with MongoDB at all, jira.tengen.com or jira.mongodb.com. They really respond, and it's really cool. They actually added it to the documentation now, so hopefully people will be aware of that in the future. And so, just as a .NET developer, I kind of quickly wanted to talk about MongoDB because I always hear Python people and Node.js people talking about it, and I love Python and I love Node.js, but I love .NET and I love C# a lot. The first thing, just as a follow-up to the first talk, was the ORM kind of tool that you guys were using. That's I kind of did a quick Google. It's built on the Tengen drivers. The Tengen drivers in .NET contain that functionality also. Being very experienced with .NET, I would say that the Tengen.NET drivers are some of the best libraries that I've ever worked with in .NET. They're completely, the API is very discoverable, it's very succinct. One of the really nice things is in .NET we have this thing called link, which lets us do queries basically on our objects, and it converts it into the underlying query. And there's very good link support in the driver. And our app was using link with Hibernate before. And so almost, I'd say 99% of the queries that we had already in link, we changed what object they were pointing to, and they just worked. The exception was in this one specific quick case where we were doing in queries, or in link it would be a contains query. And there was kind of a non-standard way that the MongoDB driver implemented that. We actually filed a ticket and they changed it, but not when we first released, so we had to use it in a non-standard way. And then subsequently we can convert back. One thing that I didn't talk about is in SQL Server, a lot of SQL Server shops, they use GUIDs or UUIDs as the unique identifier in tables. We kept the GUIDs in MongoDB as our primary key, and that's because we had a lot of other pieces of data that were like pointing to the survey still. MongoDB's native primary key is called an object ID. It's like based upon like what time, what process ID is running, and like a counter or something. I really like it. It's more compact. It's better than a GUID. You can naturally order it. There's advantages to GUIDs also. It wasn't a matter of what's better or not when we made the conversion. It was a matter of what's going to fit with us because we're using both at the same time. And there's clearly no native object ID type in SQL Server. So we kind of had to have a common ground. From a functional perspective, it's kind of a disadvantage to work with GUIDs in MongoDB, specifically when you're in the shell. When you're in C#, it's just a GUID. It works perfectly. You don't notice it. But when you're in the shell and you're like doing queries, just ad hoc looking at things, GUIDs are not represented as their like string representation. They're actually represented as binary, base64 encoded binary data. And so when a support ticket comes in and it's like this user ID has a problem, we can't just go like query this user surveys with this ID because the ID is in a string form and clearly it's not base64 encoded or any of that. So my one tip for that is in the C# drivers Git repository, there's this file called uuidhelper.js. That file has at least rudimentary functions in it to take a string GUID and convert it into a base64 encoded binary data object in the shell. It's still extremely crude and it's still extremely not ideal. When we query the data, it says bin data 3 comma gobbledygook. We gotta like take that into a variable and then do .2 cs uuid and then we'll get the GUID. It's not. I want to just see the GUID in there. And there is a ticket about this. The real big crux of the problem where they can't do that right now is that unfortunately the UUID implementation in other languages is slightly different. Specifically with the way that the bytes are ordered. And so in Java, it uses big endian for all its bytes, and in C# in .NET, it uses big endian for the first 16 bytes and little endian for the last 16 bytes. And object, so it's just giving it what they could have implemented it to normalize it between the two, but it wasn't really like the biggest problem when they first implemented the driver. Now everybody has unnormalized GUIDs, so this is the state of the state. And so that UUID helper also contains things for Java UUIDs as well. So it's kind of for both. But I would say that I think the team's perspective, that's one of the biggest challenges. So just to wrap up, MongoDB was definitely a game changer for TeacherTrack. We're talking huge performance here. Pages took 10 seconds to load sometimes in more rare cases. Obviously, that's not like the most applicant-facing cases, but I want every page to be extremely fast. And so MongoDB was definitely a game changer, and it allowed us to think in documents. And I think that's been a huge mental change for me. And I don't want to work in a database, a relational database anymore. Tables are limited. The other thing is Tengen is a great company to work with. We depend on MongoDB to store our data, and arguably data is one of the most valuable things that we have. And knowing that the people behind it were available for us is definitely a huge plus. As far as conversion goes, pre-conversion and incremental conversion are definitely the keys to minimizing deployment time. And try to multi-thread. Hopefully you guys are awesome programmers. And most importantly, the whole team at TNCP rocked it. And I would not have been able to do it without any of their help. I mean, we had a huge application that was running for years, and we picked up the database, and my manager, Allison, kind of explained it to the business people. Think about taking a huge house and picking it up and then driving it down the street and putting it down on another foundation. That's essentially what we did here. And you can't do that if you don't have an awesome team. And I think that we did. So, cool. And that's it. Advanced pages. So my blog is architectryan.com. If you guys have any questions, first of all, I'm posting these slides on my blog. If you guys have any questions, there's definitely a cool contact form that I just got working last night on it. Other than that, I'm going to be around after this. And thank you guys so much.